All right, what's up, Algebra 1? So today we are doing 5.1, which is rate of change and slope. All right, so our objectives are to find rates of change from tables and also to be able to find the slope, both from tables and graphs. So we'll get right into it. All right, so pretty simple. We have problem 1 here, finding rate of change using a table. So it says the marching band. The table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? Okay, and then we have the table on the right side with the time in minutes as the x value and our distance in feet as the y value. Okay, so our rate of change, as we know, is our change in y over our change in x. Okay, so in order to calculate it, basically, we're going to look at the changes each time. Okay, by the way, this says it to do a little bit different, but they're really doing the same thing. So don't make a big deal of it. It's not a big deal. 260 and 520, the difference between those is that it's going up 260. All right, here we have plus 260 and plus 260. Okay, so that's our y, or our numerator. And then our denominator, we've got plus 1, and plus 1 for all of our x values. All right, so we have 260 over 1. So the slope, or the rate of change, is going to be 260. All right. So again, pretty simple. Not difficult. Go ahead though, and look at number 1. So you're not doing like a new or a different problem, but it is definitely a good one just to think about. So go ahead and give that a good thought and write down your answer for it as well, and then we'll move on. All right. So for problem 2, we're looking at finding slope using a graph. Okay. Basically, the same way we have y over x for our rate of change, that change in y over the change in x, this is the same thing, right? So we have our change in y, which we're going to call our rise, okay? And then our change in x, which we call our run, okay? So if you think about it, the change in y moves up and down, or it rises, or goes down, I guess, falls. And then your x is called run. That's pretty easy because you run across the ground or the horizontal surface. You don't run up a wall. If you are running up walls, that's pretty cool, and you need to show me how to do it. But typically, you're going to be running on the x-axis, which is horizontal. Okay. So if we look at A, we have that we rise 2 units and then we run 3 units. Okay, again, rise over run, so 2 over 3. So our slope is going to be 2/3. All right, and then for B, same thing. We have our rise, which is down 4. Okay, and then our run, which is right 5. Okay, so since it's down 4, it's going to be -4. And then our run, right 5, that's going to be +5. Okay, so we have -4/5. Okay. That's it for looking at a graph and finding the slope. Again, not difficult stuff, but go ahead and do the got it problems A and B, just so that you are clear that you know how you're supposed to do these. Sorry, I'm losing my words a little bit here. But yeah, and then I also want you to go ahead and do C as well. Again, it's just requiring you to think a little bit more intuitively about what we're doing here. All right, and a little bit more abstractly. So go ahead and try those 3 on your own. Pause the video, do that, and then we'll resume on again. All right, once you've done that, we're going to go ahead and skip on to problem 4. All right, So there's a few things to look at with problem 4. First, it asks us to find the slope of each line. So if we look here at A, we're given the points -3, 2, and 2, 2. Okay. Now, one thing we haven't really talked about yet is our formula for slope. So this is really important that you get written down. We have slope equals y2 minus y1 over x2 minus x1. All right. So, yeah, make sure you get this written down. Okay. One thing I will add to this, it doesn't matter which y value you use as y1 or y2. And then the same thing with x1 and x2. It's just important that you keep it consistent. Okay, so if you use, if we call these A and B, if you're using the y value for A as y1, then that means your x value for x1 needs to also come from A. All right, so just make sure that they're consistent in that way. Otherwise, you're going to end up typically it'll be negatives that shouldn't be negatives. But that's not always the case. So just make sure that you get those two in the right order. All right, so when we use this slope formula using the points A and B there, we have y2. I'm going to use B as my second one. So y2 is going to be 2, and then minus y1 for A, which will also be 2. All right. We have 2 minus 2 over, and then we have x2. And since I used A as my, wait, did I use A? Uh-oh. All right, so funnily enough, I forgot which one I used for x2. I'm going to assume I used B just because it's the second one. So I'm going to use B again and put that for x2 there. And then my x1 is going to be -3. Now remember, we're subtracting -3, so you're going to have two negatives there. So that's going to be the same as 2 minus 2, and then 2 plus 3, because minus a negative is just adding a positive. All right. Now, I did say I wasn't sure which one I used for y2 and y1. The good thing is these are the same. So it's not going to make a difference. If they weren't the same, I would have been able to tell which one was y2 and y1 in the first place. So this one works out for us. All right. But we've got 2 minus 2, which is 0. And then 2 plus 3 is 5. So we have 0 over 5 for our slope, which is the same as 0. All right. So our slope for A is 0. So any horizontal line is going to have a 0 slope. Okay, so 0 means it's horizontal line. All right. Yeah, so then we'll go ahead and move on to B. So for B, our points are, we're going to call A the top one, so -2, 1, and then we're going to call B the bottom one, or the bottom one B, I guess, and that's -2, -2. All right, so same thing. We're going to use our slope formula again. All right, so this time I'm going to use B for sure as my y2. So we're going to have -2, and then minus y1, which would be 1 from the A, and then that's going to be over x2, which is -2 from the B, and then minus x1, which is going to be minus -2 from A, or plus +2. All right. And from here, I'm just going to simplify. So we have -2 minus 1 is -3, and then -2 plus 2 is 0. So we have -3 over 0. All right. Hopefully you remember you can't divide anything by 0. All right. If you try to type in -3 divided by 0 in your calculator, I think you get syntax error. You get some error message. I don't remember if it's syntax or not. All right. So if you end up with 0 as your denominator for your slope, that means your slope is undefined. All right. If your slope is undefined, that tells you that you have a vertical line. All right. So for A and B, that's basically how those work. So remember, 0 is horizontal, undefined is vertical. All right, that's going to be really important that you remember that. Okay, and then we're going to go ahead and I want you to look at 4A and go ahead and do 4B as well. All right, once you've done those, you are good to go on this lesson. So hopefully your notes are good, and we'll go over it in class, and I will see you guys then.